anywhere on that. That test only moved to the 4th. And last we left off was section 1.4, so we're going to start in 1.5. Now this is titled Bias in Sampling. Bias in sampling. And no matter how well you do it, no matter how hard you try, you do things randomly, making random phone calls. There appears to always be some bias in sampling. So we're talking about the major types of bias that can occur. And what I'm talking about is like someone does a poll 2 weeks before an election. You get the results, you're like, okay, and then 2 weeks later you realize, man, that poll was wrong then. You didn't get it right. Well, maybe something happened in those 2 weeks. Nah, I mean, it's just bias that can occur. And these can hit on some major types just to think about. The first type is voluntary response. Another type is under coverage of the population. All right. Under coverage of the population. Or non-response bias. And lastly, response bias. We'll talk about all these. All right. I'm sure a lot of you read through section 1.5, kind of talks about this stuff. You'll see these terms in there. Some of these seem like the same thing, so don't get so worried about that. Like if you're like, I don't know if that's non-response bias, but that's voluntary response, I'm being honest. Just that you're recognizing there's some bias. Feel free to list both of them if you're confused or not sure what to put. Voluntary response, what's a good example of that? It's like an internet poll. So let's say like a website like Drudge Report has a poll after there was a debate like on Fox News. There's one tonight, correct? Mm-hmm. Yeah, I think someone's not participating though. I don't think Trump's gonna. But you know, it's like right after the poll, they'll put it and go, who do you think won? And you go in there and you click on it, it's real quick, right? Gives the results. That one, last time I think the Drudge Report poll was over 1 million. I mean, over 1 million people responded, but still, it's what? It's voluntary, right? And only people who go to that website do it. And you had a point of question. Go ahead.
It's only people with strong opinions.
Yeah, there you go. So it's like someone has strong opinions. So he's recognizing a bias there. It's like someone who's going to vote, right, in an election, maybe they're just, you know, not even aware of this and all this. They're not participating in this, so there's some bias there. So very good point. He's saying, oh, those people have a strong opinion about this, so it's voluntary. So that's a good example of that. Under coverage of the population. I mean, I'm thinking about, you can think of someone like a homeless person, right? You know, if someone's making phone calls, do you think the homeless person's going to get the phone call? No, you know? Or maybe someone's, you know, away in the military, someone's away at college, and they're trying to get in touch with them, and they're not there. And so sometimes they're just missing parts of the population. Non-response bias, I put a star on that. I'm famous for that. And when you have caller ID, when you get on your cell phone, if you don't recognize that phone number, do you answer? No. Same here. I don't. I'm not picking up. So maybe someone's trying to poll me, just ask me, you know, hey, 5 minutes of your time, I want to ask you who you're going to vote for, etc. If someone's trying to poll me in some kind of sampling process, I'm not responding. I'm not responding to it, right? Non-response bias. But both of these sometimes go together, because you might go, but I'm not responding, so it was voluntary. And so I didn't want you to get so worried about that. But what's a great example? At the end of a course, can you do those student opinion forms? Is it mandatory?
No.
No, so it's voluntary, and so it's like up to you. Usually, you know, we just brought in the sheets at the end of class. I said, I'm going to leave, and you do it. Students are very kind would do it. But now it's internet. Now it's off the internet, and we're like, you know, hey, it's voluntary. You get these emails. And you can imagine the response rates actually went down. Because it's just like, voluntary. And they like to think or not. But I'm sure, going back to your point, what if they have a strong opinion about that instructor? You know, the instructor never showed up for a few weeks or something like that. They might get in there and say something. Hey, response bias, good example of that. Sometimes the wording. the wording in the question may mislead someone or influence a person to make a decision on the way the question was worded. Okay? So it could be the wording in the question. Like, what's a good example? I don't know. Someone's polling about, like, children's sports. And they start out and they go, in the past year in the United States, 5 children have been injured or have died from playing football. So what are your thoughts about allowing football to be played at, age 13, 18? Something like that. They give you some shocking statistic in the question, the wording. That may indicate or mislead some. Oh my gosh, well, I'm going to say no, right? So the wording can sometimes influence a reaction. All right. Now I'm going to give an example. Something actually happened. And I'd like you to raise your hand and recognize any type of bias in this type of sampling method. And when I'm going back to, this is back in 1936. It was prior to the election as they're voting for the United States, president. And these two people are running. There's a gentleman named Alfred Landon. And he's running against Franklin Delano Roosevelt. So they're running in Literary Digest. Like, I've never heard of that. There's probably a reason behind it as we go through this. But you hear the whole story. Literary Digest decides they're going to poll everyone. Maybe they're going to put themselves on the map because they're going to be the ones who kind of basically predict who's going to win this election. So they're going to do this huge thing where they're going to send out 10 million mailers. And they do that. They send out 10 million mailers to people to have them send it back indicating who they're going to vote for in the election. I mean, that's a lot of mail, isn't it? Especially in 1936. This is Literary Digest, true story. They actually got 2.4 million responses.
From 10,000 mail?
Yeah. So it was 10 million sent out. They got back 2.4 million responses. Which you might go, wow, that's a lot. I know. But a lot of people didn't respond, do you agree? But they sent out 10 million mailers. 2.4 million responded. How did they get the names of these addresses? Or how did they get these addresses and stuff? They used phone books back in 1936. This is what they used. If someone belonged to some professional organization, like a club, maybe like a golf club, or they subscribed to a magazine in 1936, they got their address that way. So this is how they got all the names and the addresses, and they sent them to them. Well, they predicted that Alfred Landon was going to blow away FDR, like landslide. Now, does anybody remember our President Alf Landon? No, they totally got it wrong. Do you agree? FDR won, but they had this predicted as the winner. A lot of money spent on this, true? That's why now we're like, what happened to him? Yeah, it kind of knocked them out, didn't it? It didn't go so well for them. So what's going on? They thought they had it right. Well, there was major bias in there. So does anybody want to indicate some biases that occurred? So that's what happened. It was bias in their sampling method. Anybody notice one that occurred in this? You got one. What do you think?
Non-response.
No.
I love it. Yeah, non-response. If you want to go with voluntary response too, everyone, saying the same thing, I love it. Because non-response. He's saying non-response. They sent out what? 10 million flyers. Only what? 2.4 million responded. It's a lot of responses. A lot of people didn't respond. Do you agree? A lot of people got to go, not mailing it back. Does anybody indicate another one? I think it's the one that really influenced their, the results there.
That's what I was going to under coverage.
Love it. So these were great, just as under coverage of the population. So it's 1936, coming out of the Great Depression. Does everyone have a phone, a telephone in 1936? Remember how they got all the numbers? They got them from the telephone book. Did everyone have a telephone? You want to hit the entire population. What's representing the population? I don't have a telephone. So they definitely missed people with this. Does that make sense? And here come out the voters for the real election. FDR wins. That's very good. I guess I can't say this. I wasn't sure of the wording. I don't know how they asked it. Unless you might say, well, who they list first? Sometimes the person listed first might get more votes if people don't know either one or just want to send it back. So, but great. Hey, for your test, I'll give a true story. I'll give something that really happened. I asked that you list just at least one bias. Could you do that for me? on the test, list at least one. If you notice more than one, you can. That's what I mean. You're like, oh, this and this. But out of these, we'll list at least one bias that occurs. And it's good stuff to think about throughout our whole course as we do things. Or as you notice things, if you're into, whether it's politics or anything else, and you see the polling going on, and you know, I think next week they'll be in Iowa, and you go, gosh, they got that wrong. What happened? I mean, you really can go back. You probably spot some of these biases that occur. Especially that one. All right. So that's bias and sampling. And now we're going to move into 2.1. All right. This is organizing qualitative data. Organizing qualitative data. 2.2 is going to be organizing quantitative data. So do you want a major difference between qualitative data and quantitative data?
It's the same as like qualitative and quantitative variable, kind of like that?
Brilliant, that's it. I'll give you that. That's excellent. All right, that was really good. I'll give you an example. I mean, I'm thinking of shoes, right? If I do shoes colors, isn't that qualitative?
Yeah.
White, red, black, green, blues, colors of shoes, that's qualitative. But what if I do shoe sizes?
Quantitative.
Ah, that's quantitative. All right, does that make sense? See the difference? So when you're thinking about this, you know, you have data that's, you know, we have qualitative data and we have quantitative data. All right, so I'm going to start with making something called a bar graph. And when this is in 2.1, you've seen bar graphs. I know, for years. I mean, you can go way back. You've seen bar graphs before. They got these rectangular bars, stuff. Well, bar graphs are used to describe qualitative data. So if I did colors of shoes, over here, we can list this as the frequency. The frequency. That's a count. That's a count. And then here I could label this as color of shoes. And let's say I've got brown shoes, black shoes, white shoes. I'm looking around. What color are those? I'm color deficient. Great. Gray shoes. And we go in here and we go around. We can do this for the classroom. Hey, raise your hand if you got brown shoes. And I have to count them up. I've got 1 and 2 and 3 and 4 and 5, 6, 7. I see 7 people with brown shoes. So what do? I count up 7 tick marks this way. Little tick marks, 1, 2, 3, 4, 5, 6, 7. Brown shoes, 7. If you want to put the 7 above here, you can. I like to do that. Then you don't have to look all the way over here to the left, right? You can label it right above this. Haven't you done this for years? I know. You're like, man, I've done this before. Brown shoes. How many? We got black shoes. All right, there's a lot. 1, 2. I do 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11. 8, 9, 10, 11. When I make this rectangle, I'm doing this with freehand here with the chalk, but I should make it the width of the rectangle appropriate in terms of being similar to the width of that rectangle right there. You know, because if I made it much wider, you might go, hey, there's bias in your bar graph, right? But we use software for this.
Oh, so they don't touch each other?
That's right. I love it. So it's the first thing to indicate. He goes, they do not touch each other. They have spaces between them in bar graphs. So bar graphs, when you're describing the qualitative data, we're organizing qualitative, there's gaps between these. But we'll keep that width the same. Hey, white shoes. 1, 2. just 2, all right? About the same width. Yeah. 2. I like to put the numbers on top here. If you use Microsoft Excel, it has that option. You can use that option. And this is real easy to do with Microsoft Excel if you want to do this stuff. How about gray shoes? I know we got at least one. 1, 2. We got 2 of them. I guess I could title the other one Other. Anybody have anything else? Other type of shoes? We got 1, 2, 3. Anyone get this program? Awesome. We label it, this is frequency, and when the word frequency, that's like how many? How many do you have? What's the count? Think of it as a count.
Do you have like a set of instructions on how to make different graphs in Excel?
I can provide this for you, if you want to, absolutely. Yeah, if you want to do it, and when you do it, you're gonna find it, it's, I find Excel very user-friendly. So when you're doing it, like a couple clicks, you put, even when it's quantitative, put the numbers in there, you look at, you're like, oh, we're gonna do a histogram in a second. Click on the histogram, I do the options, so I'll be glad to provide it for you.
I was gonna ask, when you're doing bar graphs, in order for that to be correct, it would have to be frequency on the left and the color on the bottom and not the other way around.
Correct, very good. We always put frequency over here like this is the y-axis.
Even when you do quantitative.
That's right. So when you do, I love that, Tia. So when you're doing quantitative, you're like, this is gonna say frequency.
Okay.
This will say frequency, and it's gonna be a count. And we're gonna actually organize quantitative data in a second.
So you said color was qualitative, right?
That's right.
But if you organize it by size, it would be quantitative, right?
That's right. And we actually, when it's quantitative, Mia, so you go, what do? We don't call it a bar graph. There's gonna be another name. It's gonna be in 2.2, and we'll get there. It's called a, you probably heard of this, something?
Histogram?
She knows. It's called a histogram.
But so my question was, why can't if you're counting like there's 4 size 10s, why can't you do it like this?
I got you. Like, because, you know, like size 10s, you might say size 11s or 11.5s. When it's quantitative, sometimes these quantities, they can run it, they could be numerical values like, I know shoe size is like 10.5, 11. But think of things that could be like up to 10.99999 or 10.97 or 10.62. I'm thinking of something like rate of return on some some investment. You're like, oh, it's a 6.72% return of investment. And it comes into so many different options. You and I would be going crazy going 6.72, 6.73, 6.5. But I got you if if it's just shoe sizes, 10.5, 10, you know, you could make something like this that people would be able to read it and understand what you're talking about.
Okay.
But still it would be, when it comes to those values, it's really quantitative. So
Okay.
Mia, good question. All right, hey, has anybody ever made a pie chart? I won't make you make a pie chart. A pie chart's got the circle, it's got the little things, you know, you have to come in here and bring your little protractors and your compasses and stuff. That's where we use software, but what does it do? It puts it all in a circle and breaks it into these different sectors and stuff. But that's also organizing qualitative data, those pie charts. And I know you've seen those before. What we're now going to do, and we're going to go into, before we do 2.2, I'm going to provide a frequency distribution for you. You've seen those before. A frequency distribution. I'll take one from the book. This is on page 75. I'm going to take number 14. We're just going to do 14A. And I'll write this down. They already give a frequency distribution. We're going to construct something else. So here's the frequency distribution given to us, provided for us in 14A. It's about wearing seatbelts. So they titled this response, and they titled this frequency. It's just a table. They asked people about wearing seatbelts. Well, one of the responses, I do not drive a car. See, the question asked to all these people was, do you wear a seatbelt when driving a car? Well, one of the things, hey, I don't drive a car. Another type of response is never. Rarely. Sometimes. Most of the time. And then always. And all these numbers were private. 249 people said I do not drive a car. 118. 249. 345. 716. And overwhelmingly, 3,093 said always. All right. So that's a frequency distribution right there. You've seen these before, huh? Of course. You probably saw one earlier today. You popped open the internet and you're looking at something. It's just a frequency distribution. Here are the frequencies. So the question again, how often do you wear a seatbelt when driving a car? These are the responses. Who conducted this? And when this was the Centers for Disease Control. All right. What we're going to do, we're going to construct what's called a relative frequency distribution. So we're going to construct a relative. So let's underline that word. Relative frequency distribution. All right. So what we're going to do, and let's just put a vertical line here. And right in here, we can fill in our relative frequency distribution. And we can title this relative frequency. So when you hear the word relative, and when I want you to think percentages, that's what I want you to think. And just by me putting that percentage symbol up there, I have a feeling a lot of students in this class already know what to do. But we'll explain it. He was just talking about step by step, like a step by step. We're going to do step by step procedure here on how to do this. We're going to find out relative frequency distribution. Hey, what do you mean by relative? I want you to think, oh, percentages. What percent of the people responded as, I don't drive a car, or I rarely wear my seatbelt? Percentages. All right, so it's a two-step process here. Someone's going to tell us. Raise your hand. Who knows step one? Watch this. Mia, what's step one?
Add all the frequencies together.
Add all the frequencies together. Mia, excellent. She goes, you're going to have to add all these up. We're going to add all these up. Hey, there's a symbol I want to introduce to you. You're going to see it a lot in this course. It's the symbol for adding things up, summation. It's the Greek symbol sigma. So I'm just going to write on the board. It's funny, it looks like that. I'm writing that just to indicate, see that thing? Can you see it? I'm going to draw it big. They call it sigma. It's a Greek letter sigma. It's capital sigma. In the Greek alphabet, they got capital and lowercase letters, but it's capital sigma. It means summation. So when you see that symbol, you're thinking, I'm adding things up, huh? Hey, we were just talking about Microsoft Excel. There's a button with this in the top menu. So if I highlight a bunch of numbers in a spreadsheet, I click on that, what will it do?
Add them.
It'll add them up. And it'll put it in the cell right below. I love it. I use it all the time. I use it all the time. Right? So anyway, relative frequency. First step, because you're going to have to add all these. And my rule of thumb in the classroom, we'll get someone will do it for us, and then we get someone to verify it. And don't worry if you mess it up, because sometimes that happens. You put the wrong number in, you know. So once we know two people get the same number, we know it was done right. Anybody do it yet? What'd you get?
4,770.
So 4,770, I got a hand from Tia going, that's right. So there we go. And don't worry if you're sitting there going, I didn't get that. I need you to go back and go find the number you typed it in correctly, or maybe it was reading it off the board here. So that was the first step. We had to add all these up. Me, that was good. What's the second step? Anybody know?
Take percentage, divide the.
I heard it. Divide. Does everyone agree? That's the word. We're gonna have to divide. We're gonna have to divide each of these by 477. So we're gonna take like the 249, pull out our calculator, and we're gonna divide 4,770, right? And we're gonna hit enter. Now, aren't a bunch of numbers gonna come up? We expect that. It's not gonna be perfect. Let me get a decimal and all this. See how this looks. We'll talk about, how are we gonna estimate this? So at some point, 249 divided by 4770, right? 0.05220125579. And when I want to put this in a PowerPoint presentation, I got to present this to like 800 people tomorrow, let's say. I don't think I'm going to write out that entire number. Do you agree? It would look silly. So can I round it? Absolutely. It's for a presentation. I want to do this for a presentation. So I could write this as 5%, right? So first of all, I could write this answer like this. That's okay. Want to see how I wrote 0.05? But if I want to write it with that symbol, what do I have to do?
Multiply by 100.
He goes, you're going to have to take this, multiply 100, and what do you get? 5. 5? Excellent. So I'm going to put that. Go ahead.
What's the standard decimal place you use? Do you use 3 decimal places or 2 decimal places?
Well, see, that has 2 decimal places here.
But
Do
what do you
this
typically
course, how about 3? All right? And so I'm going to write this as 0.05. If you want to put the 2 there, excellent. I can write this as an integer, though. So I'm going to put this integer 5% here. Either of these are fine. Is that okay with both of these? Awesome. Now, don't do this. What's wrong with that?
No, that's 0.05.
That's not mathematically correct, is it? That's not correct for what we're talking about. It's either 0.05 or 0.052 or 5%. Sound like All right. So now, what happens though, I'm gonna put this back up. When we keep doing this, I keep rounding and estimating, and I go up 2 decimal places, right? Each time. What I can get is some kind of accumulated round-off error. And what should all these percentages add up to? 1. 1.0, and all these should add up to 100%, right? I'll put that way down at the bottom. These should add up to 100%, and this should add up to a 1.0. Well, if I keep rounding like this, and rounding, you know what can easily happen? I can get my sum to be 0.99. Or I can add them all up because I keep rounding, it might add up to 1.01. And I just recommend, if you can put that in a presentation, you might get a heckler who in the audience is like, hey, that's not adding up to 100%, that's adding up to 101%. So when we round these, we can always go back and tweak something if it's in the middle, just to make it look appropriate, all right? Is everyone okay with this? Absolutely, that's great. We could write like this, 5%. I think I'll do integers in my presentation. So when I'm gonna write 5, and I'm gonna put percent. Now, what's this next one? Anybody get it? 2%? All right. Hey, can you give me a few of those values off the decimal point? I'll write them down.
0.02473.
Just so people can see what she did. She got this decimal, and she's going to call that 2%. Cool. Now, when it comes to rounding, I agree with her. What was after that 2? Stare at that. What was it, 4? So if it's after the 2, it's a 0, 1, 2, 3, 4. We'll round down to 2. But if it's like a 5, 6, 7, 8, 9, I could estimate it rounded up to a what? 3? But I do want to say this. There's nothing wrong with this if I'm just estimating. That 4 is kind of in the middle, isn't it? So it wouldn't be wrong as I estimate if I rounded this thing to 3%. Okay, if I want to. Because I'm just making this in my presentation. You wanted to somehow give what? Some number, and you're like, the more values I put down, I think it's going to confuse my audience. I'm like, listen, the people who responded never was like 2 or 3%, right? Hey, this is going to be the same as that. All right, what's this one?
0.07232.
Ooh, 7%. This one? 15? 15%? And what's this last 3,093? 65%. And everyone, would you take a second? I think I'm going to present it like that tomorrow to my audience. can we make sure these add up to 100%? And if they don't freak out, go, that's expected, it happens sometimes. I'll go back and tweak one, and I might tweak that guy.
Yeah.
Because he's kind of, see this? That's a 4. I can make that 3% if I have to. What does this add up to?
99.
99.
Ah, this is adding up to 99% right now. So when I'm putting my sad face, what went wrong? We expect this. No, really, that can happen. I was rounding these. That's what can happen. So I go back in, I'm like, well, this one was, when Tia read that to me, I was like, 0.0247. There's nothing wrong with me just rounding that to 3% for my presentation. And I love that. So hey, it's good right now? That look good? You can do it like this. You could write this way. Some people like to do this. They prefer decimals without the percentage symbol. 0.65. You know, of all the things we do in this class, this is one of the most important things actually. Because this is what sometimes gets students, they get all mixed up. They're like, oh, I gotta write it like this or write it like this. If you want to be more accurate, that's totally fine. But I'll explain to him if you want to go to 3 decimal places. Absolutely. Everyone good? Right. Hey, so now we're going to 2.2. 2.2. What's this one titled again? Organizing. Quantitative. So I want to make one of these funny little, again. Me and I were talking about this. She didn't know the name of this. It's called a histogram, right? And when to organize quantitative data, similar to that bar graph, this is called a histogram. Histograms are used to organize quantitative data. So first step we're going to do is you and I are going to construct a histogram. All right, where's the data? Well, today I decided I want to use data that everyone in this class can see. And even if you don't have your textbook today, you're like, I can go back tonight and I can go look at this data. So I'm going to use table from the book. This is in 2.2. Table 8, I was kind of bored by that. Number of arrivals at Wendy's, blah, that's kind of lame. No interest. I want something with, with these decimals, because those can confuse some students. So I'm going to go to page 91. And I'm going to use table number 17. So if you're sitting there right now and you're like, I don't have my textbook, it's in a car that's buried in snow from the blizzard. I want you, well, I'm taking the table from page 91. It's got a lot of values there. We're going to construct a histogram from that. My goodness, how many values are in here? 1, 2, 3, 4, 5, 5, 10, 15, 20, 25, 30. There are 40 values in this table. Okay? And I don't have to write them on the board, to write all these values, because I'm sure you can go look at these at home. A lot of you have your textbook out and you see these. Looking through the table, I wanted you to scan it. What's the lowest number about? What do you see the lowest number as? Just scan over it, like, oh, how small did they get?
3.3.
I'm hearing like 3.3, okay? 3.2, how high did it get? How high did it get? 11.7, oh, there's a 12.0. So when we get numbers like around 3-ish, going up to like 12-ish. All right, and you go, well, what is this? And when they said this was the 5-year rate of return. 5-year rate of return. What were these, mutual funds or something? Yeah, these were 5-year rate of return of some mutual funds. Some were at 3%, some got up to 12%. I know the one I want. I want that one that was getting 12%, right? Rate of return on my money, my investment. But some are down at 3%. Okay. So here they are all listed. So this is 5-year rate of return of these investments. We're going to construct a histogram from all these. All right. So when this is at, I want you to pay attention to the directions. You just asked me a good question about like rounding, right? Well, in these problems where you construct a histogram in the textbook, it'll be specified what should be your class width, all right, and your lower class limit. So I'm going to write this down. With the first class, I'm going to write having a lower class limit of 3 and a class width of 2. I'll read it to you again. Having a lower class limit of 3 and a class width of 2, I'll put a comma, and when I want you to construct a histogram from that data. That represents all that data.
So you mean like 3, 5, 7, that's
I
all?
love it. You know what I mean? So we'll go through this because we're looking at here. What do these words mean? Limit, lower class, 3 and 2. So when we get this thing set up, all right, very good. What's the word over here, T again? Every time?
Frequency.
Frequency. So I'm going to put frequency here. You better, when we're still going to do this count thing, we count, oh, there's 6 of these, there's 8 of these. But down here, I'm going to make tick marks. I'm going to make some tick marks. You go, well, that's the origin, huh? Well, welcome to statistics. What did we say the lowest numbers around in that table?
3.
That's why when I asked this question, I'm like, I'm going to ask you to do a low class limit like 3. There's nothing in the 1s or 2s. So what do I do? Do I have to go 0 and then 1 and 2? No. Beauty of statistics. And when you start right here, you can just do a little squiggle. Just do a little squiggle off that thing. And I can put my lower tick mark, first tick mark at the number, what's that? 3. So on your test even, when you see this question asked, with the lower class limit of 5, right? Do a little squiggle and your first tick mark would be at what? 5. Does that make sense? Cool. Now, there's going to be more tick marks. And so how far do I spread these apart? That's that word class width. So if the class width is 2, what do y'all think I should make this next number?
5.
5. Add 2 to it, right? So I'll put a 5. How about here? 7. 9. You know what's neat? I'm not even looking at the table. I could go too far. There's nothing wrong with that. There's nothing wrong with going too far. I didn't hear anything about anything in the 15s. The only thing is, will I have any rectangles here? No, that's what it'll indicate. So there's nothing wrong with going too far, but I had to make sure I did that lower class limit. So to see how this is appropriate, let's say I'm talking about values of homes. There's not many homes worth $3. But maybe like you're like, okay, I'm going to start my histogram at 100,000, right? And I go $100,000, and I go by like 20,000 each time or something like that. Does that make sense? Yeah. All right, cool. So now when this is the only tedious part. Oh, we're kind of go ahead.
I don't understand what is the class width number.
Oh, so are you okay with the lower class limit?
Yes.
Good. So we put that number here. For class width, when they provide that number for you, I want you to add that to this.
So you mean just only 3 plus 2 and equal 5?
That's right. And then you continually add 2. And then what we're going to do, it's going to be real easy. We're going to go to this table. You and I are going to count. It's kind of tedious though. We're going to count how many numbers are between this 3 and this number in the table. All right? And let's say there's 15 of them. All right, and I'm going to go up 15 notches. Does that make sense?
Yeah.
Cool. Now here, I got to be very, very careful on how I explain this. The number 5.0, if that's in a table, that's where students get confused. Do I put 5.0 in this rectangle, or do I put 5.0 in this rectangle because it's right on the line, right? That one, 5.0 would go in this section. So what I'm talking about, see right here? I'm actually going to count how many numbers are between 3 and 4.99 in that table. I'm going to count. We're counting how many numbers are between a 3 and a 4.99 in that table. Whatever that integer is, that's how high I'm going to build my rectangle. Okay? Now, it's tedious though. I have to go in here. There's software that can organize this stuff. Excel could do this. And the calculator could do it. But what we'll do is, it doesn't take that long. But let's go into this table. Can you help me count? I'm going to cheat though. I'm going to look on the next page at the answer. Can you count how many numbers are between a 3 and a 4.99 in that table? There's a lot.
49.
Is it 29? Someone getting that? 29 numbers between those? I'll look over here on that next page. Yep. So when I gotta go 29 high here. Now when I don't feel like making 29 tick marks, do you? So what would be appropriate? I could go by what, 5s? Yeah, I'm gonna do that. How about we'll go 5, 10, 15, 20, 25, 30, and there were 29 numbers between a 3 and a 4.99 in that table when we counted them. And sometimes when you count them, have you done this before? You gotta like use tick marks and you slash, right? It's a little tedious though, isn't it? I have to admit. So we go through there, but there were 29 of these. I'm gonna stop about right there. You know me, I like to put this at the top. Unless you're one of these who like to write the number really big, that's okay too. There are 29 of these rate of returns for 5 years that was between 3 and 5. These were actually in percentages, 3 and 5%. Oh, the other thing is I'm writing this, shouldn't I label this down here? So you go, what was this? This was a 5-year rate of return. They were in percentages, so I'll put that in parentheses. 3%, 5%, 9%. But it's quantitative. Is that okay with? Hey, everyone understand how we figured out this number? Even if you don't have your textbook right now, we actually went in the table. It was a little tedious, and we had to what? Count all the numbers that were between 3 and 4.99. Now, what do I do here? I have to go back in there and count how many numbers are between a 5 and 6.99. Okay. How many do you get?
5?
Is it 5? All right. Anybody else get 5? Now, what's different about the histogram in comparison to the bar graph? They touch. Look at this, everyone. This didn't happen in the qualitative data when we did the bar graph. You put these side by side. So you remember that? Histograms, these are like, whoop, right against each other. Awesome. Now remember I said there was only 40? What's 29 plus 5 already? 34. How many data do I have left? So I got to figure out where the 6 values are in this rest of this stuff. How many numbers are between 7 and 9? There's not many, are there? Or I should say between 7 and 8.99. How many are
That's
there?
one, right?
Just one?
Yeah.
All right. There's one high, huh? How many between 9 and 8 and 10.99?
9 and 11 is 4, right?
4?
Yeah.
Someone else get 4? Take them
One.
off. All right, 4. Just counting right. And lastly, when there were none this high, but how many were between 11 and 13? Just one? Or there's more than one? I see 11.7 and 12. Are there 3 of them?
Yes,
29, 5s, 34, 35, 39, 42. There are 2 too many. Because we should only have 40, right?
There should be
There
only
were
2
two
between
between
that
9
and
and 11.
I love it. So we go back, we go, everyone, this is a great check. We're like, here, a sad face. Hey, what's wrong? Because you and I know that this plus this plus this plus this plus this should add up to what? 42. And we're like, what's going on? We go back, we look, and I'm hearing it. They're saying actually between 9 and 10.99, there were only how many? 2 of them. And now it works out perfectly. We catch that. And it happens, you know why? It's kind of tedious counting these numbers or time. When I was going in there, you're like, when you make the little, you're like, all right, one of this, 2 of these, 3 of these. You can use the software for this, but I'll be honest, by the time you did this, you would have that stuff entered in there anyway. So, I mean, it's nice to use this. It's nice to use Excel to do this stuff. Yes, absolutely. You're doing this in a presentation in front of a large crowd, or you're going to do this for a report, you're definitely going to use Microsoft Excel or some kind of software. Oh, now I got a happy face. Do those all add up to 40? All right, great job. Super. Hey, double check. We got the word frequency. We labeled this. Everything's together. Got our little squiggle. We left some space there, right? All right, hey. Now letter B. We're going to describe the shape of the distribution. So I'll go over here and do that. Doing a great job with this. Letter B. Let's call that letter A. Letter A was constructing the histogram. Letter B, I need you to describe the shape of the distribution. Okay. Describe the shape of the distribution. What are the three most popular? Well, the first most popular shape you're probably going to see, everyone, I can go over here and organize a little chart. I'll show you where it is in the book. Probably the one you're going to see very, very often is a distribution that goes like this. Goes up in the middle, really high, and then it comes back down on this side. And in that case, you could say that it's bell-shaped. That would be our answer. That's an appropriate description for distributions like that. Bell-shaped distribution. Well, this thing is not bell-shaped, do you agree? This is skewed. And so I want to show you. This, if you had a distribution like this, really high on the left, and then it what? Kind of went down to the right like that. That's called skewed, S-K-E-W-E-D. S-K-E-W-E-D, skewed to the right. If you have a hard time remembering left and right, like I don't know which way to say it's skewed, could you think of this like a dog with a little tail? It's like skewed towards the tail. Okay? So what could you call this? Ta-da, what if it went like this? That was over here.
Skewed to the left.
Skewed to the left. Is that okay with that? So I bet you know how to describe this. I bet you know how to describe this on a test. What would you say for this one? Describe the shape of this distribution. Skewed right. Skewed right. All right, skewed to the right. But it's okay if you just say skewed right. Just know how to spell skewed. S-K-E-W-E-D. It's skewed to the right. That's important in our course. I want you to leave this course and be statistically literate. And what you mean is when things are bell-shaped, or your data is skewed to the left, skewed to the right, and you want to report the center, you're going to know what to do. You go, I'm going to use the mean. I'm going to use the mean words that are coming up in the next section. Hey, I guess, what if it was all flat? Everything was flat, you can use the word uniform. And everyone, if you want to see nice pictures of this, and you got your textbook right now, a lot better than what I have, would you go to the bottom of page 92? I'll put that on. Page 92, the author did a great job. Has 4 nice pictures there. Boom, 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 boom. You see some really nice images. Cool? And I want to, if your distribution was anything else, golly, make up your own word. I mean, what if it went like this? I don't see a picture like that, so you could probably come up with something for that. You got some of that, Mia? Something's really high over here. Low in the middle. Something up there, I don't know.
Inward bell, I don't know.
She goes inward bell, I love it. Yeah, inverted bell, I love it. Excellent.
Can you use Riemann curve over here? Riemann sum or something?
What's that?
The Riemann sum, if you want to.
Oh yeah, you could.
Right?
That's what this looks like. Anybody here take calculus? Oh, you just brought up a term from calculus, Riemann sum. That's exactly what that looks like. And you get the curve. Yeah, I like that. Very good. All right, everyone, I'm going to erase this. And we're going to talk about a stem and leaf plot. You ever heard of that? Some have heard of that. I see histograms every day. I'm serious. Just going through the internet. You know, reading my articles, doing my research. I see histograms all the time. I bet you do too. Bar graphs too. I'll be honest with you, I don't see many stem and leaf plots. All right. So a stem and leaf plot. a stem and leaf plot. We're gonna construct one. So I think I'll just give you some numbers to construct this. Nothing crazy. You know, this time I'm not gonna do a table with 40 numbers. But let's just say these were the numbers that came up on a test out of 100. There were 10 students. And someone scored a 24. Hey, don't get too upset about that student. They had to shove a lot of snow. So they were ready for that. 24, and then there was a 43, 43, 45. All right. And then there was a 52, a 55. 1, 2, 3, 4, 5, 6. 70. All right. So, ten students. And when they took their test, those are the grades. We're going to construct a stem and leaf plot with these 10 grades, okay? Show of hands, who's seen a stem and leaf plot before? Cool. Now I bet you, everyone, all those hands, everyone who saw them, you probably saw it when it was up on its side. I'm pretty sure of it. When you saw a stem and leaf plot, probably was out. I want to point out, I'm going to make my stem and leaf plot like the last thing we just saw. A stem and leaf plot is just like a histogram, except it's got more information. What I'm going to do is I'm going to put my vertical line here. And you got stem and leaves. So see this 24? The stem is the 2. Guess what the leaf is? The 4. Now what's the rule with this? The rule is, everyone, the leaf can only have 1 digit in it. That's the rule. Your stem can have like 8 digits in it. So, I mean, this is going to be funny, but everyone, let's say I'm talking about the number 682,943, and I wanted to make a stem leaf plot. Well, then I can use the 68294 as my stem. Guess what the leaf would have to be?
3.
The 3. I know. So anyways, the leaf will be 1 digit. That's the rule. But the stem down here can be more than 1, right? So I'm going to keep going. There's my 24. Now, I look up here. Anything in the 30s? I'm going to put my 3 as my stem. My stem is my 3. Anything in the 30s?
No.
Oh, so do I put anything here? Excellent. But I'm going to keep that 3 there. I'm going to keep that 3 there. It's just, there's nothing in the 30s. My next stem is a what?
4.
4. Now, how many in the 40s?
2.
And we'll go in order from lowest to highest. There's a 3. Is there more than 1 3?
Yes.
So I'm going to write it again. And then a what?
5.
Is everyone so far so good with this?
Uh-huh.
Doesn't this look like a histogram? Doesn't it look like a stem and leaf plot is a histogram, just has more information in it, right? It's actually showing you the numbers in there. All right. My next stem is a 5. What's the leaves?
2.
2 and 5. Anything for the 6s?
No.
How about the 7?
2.
The 8? The 9? Now I'm stuck.
No, do 10.
How do I do this, everyone? How do I write that?
10, 0.
I love it. The rule is the leaf has to be what? 1 digit. So you're telling me the stem's going to have to be a 10, and then the leaf is just a 0. There you go. And these are the grades. But those show of hands, a lot of people have seen stem and leaf plots before. When you saw these, a lot of times they were up on the side. I'll talk about that. You go, why? Why are they doing that? There's a reason behind that. I'll reference something in the book. If you're curious about me for your test, do you have to construct the stem and leaf plot for me? No. I mean, you're going to construct a histogram, you're going to describe it, but here's the deal. If I provided one for you, would you be able to analyze it and read it? That's what I want you to be able to do. If I gave you a stem and leaf plot, I want you to be able to go in there and go, okay, what's that number right there?
24.
Don't be careful, don't call that 42. That's the number what? 24. That's oh, there's no 30s, right? That means there's nothing there, but that's the number what? 43, 43, 45, 52, 55. There you go. You'll be able to read it. That sound good? Awesome.
So that's the plot completed?
Yeah, that's it. It's all done. We constructed our stem and leaf plot, we even labeled it, we said the grades. Now, have you seen these before? I'm curious. Have you ever seen these before? Never. A lot of times when I do these, see, they're not very popular because they're funny looking. Histograms seem to be a better representation because that's what a lot of people use. But sometimes these are useful for comparative reasons. So if you have your textbook, I want to show you one. Would you get a page? It's in 2.2, just at the top of page 99. And if you don't have your book, and on top of page 99 there is a stem and leaf plot. This gives you a reason, or it provides a picture of why they do these on the side. You go, I don't have my book with me right now. Well, what do they have? And when down the middle, they've got, this is fat in grams in fast food sandwiches. On the right side, they got BK. And on the left side, they get McDonald's. And they started out with the 0 as the stem and the 1 as the stem. They put the stems in the middle. Like this. And they got numbers like this, 40. So in BK, there's something as what? 44 grams of fat. Whoa. I know. So that's what we're saying. So now we know why they like to put these on the side like this rather than like this, with the stem going vertical. Because you can compare. So in just your observation, right away when you observe this, those you have your textbook, which restaurant seems to tend to have more fat in their sandwiches? Burger King. That's what we receive. Now who knows, maybe McDonald's made this
I got a
stem
question.
leaf plot.
So the
Right?
Burger King is 44 and McDonald's is 24?
Let's see. Burger King, there's a 44, but then the McDonald's, there was a 2 over here, so you have to read that as 42 grams.
Oh, 42, okay.
Does that make sense, everyone?
So
All right, great questions. So in this stem, we saw there was a 4 here, 44 grams of fat for the BK sandwich, but 42.
Okay.
So the stem's in the middle.
The stem's in the middle. And why do they do this a lot? Because of comparative reasons. You know, hey, cholesterol levels. I'll put men over here, I'll put women over here, right? You're like, gosh, what's wrong with the men? You know, and you're able to see right away. So that's why they do this.
So you can only compare it to you, right?
That's right. I know, how would we do 3? That's a good one though. I like that.
Can you make it like that?
You sure can. You sure can. Now, I won't make you construct one, but absolutely. Because a lot of students like it that way. They like to get the stem right up the side like that, even if it's solo, right? So what would this look like? I would have put the what? If I wanted to just do this solo, you could put your stem on the left or on the right, which way you prefer, and then put these leaves off to the one side. Great job.
I just want to make sure I'm reading that correctly. So for the 0, it's 7 grams. Or 7
You
grams.
got it.
Okay.
So what would this number be? You're reading it correctly. That's 7
7.
grams of fat. And you hear all these questions about this? So now we kind of know why we don't see these too often, do we? They're not, everyone websites, do you see these? And you know where I see them? I see them in like biology textbooks, things like that. That's where I see them. Hey, great job. Hey, for the last 10 minutes or so, I want to talk about section 3.1, but I'm going to leave this up here. Because you know what section 3.1's on? Measure of central tendency. Ah. Well, we can get started with that. Measure of central tendency. We can get started with it. Measure the center. Measure of central tendency. Well, can I just get it started? Sure. We're talking about measuring the middle. So I'm going to start out with this word. There's a word I want to use in statistics. It's called the mean. We're talking about the average. So let's say I wanted to find the average score in this test. Raise your hand, explain to everyone what you would do. Because people know. I'll go to Randy. How would you find the average or the mean?
Add them all together and divide by the number of,
Occurrence.
I love it. You nailed it. That one's like, if he says first you'd have to add all these up. So you know what symbol I'm going to put down? I'm going to go like that. Because that means what? Sigma. All right, I'm going to add up all the scores. Now, if you want me to put scores, I guess I can call them X's. Add up all the X's. But when we're up to the statistics, you know, if you remember back in that, this is an algebra class, but I can't call that X and call that X because they're different numbers, right? See what you do in stats? We call this X sub 1. We call that X sub 2. Don't get so worried about the notation, but then we call that x of 3, right? So what I'm going to do is I'm going to say, how about we add up all the x sub i's? This is the little formula, right? So I'll add up all the x sub i's. And then you said you have to divide by something, right? The number of what? Scores, the number of students, the number of elements. Do you remember last class I had a letter that represented the size of a sample?
N.
It was a little n. Do you remember that? So I'm going to put over lowercase n. As if this was the size of my sample. And you all know how many students were there. There were 10, right? But that's what we're going to add all these up and divide by 10, true? And I'll wait for a couple students to do that. We'll get someone to verify it. Take your time. So we're going to get the mean. And let's say this was just a sample of students. I'm going to call it the sample mean, okay? That's the formula. It's provided on your formula sheet. I just don't think anybody's going to have to look at that on a test. Do you agree? Or I just don't think you're going to have to go, let me go look up the formula for finding the sample mean. You're going to know, I got to add all these up, divide by the number, right? Yeah. But it'll be on it.
61 is the average.
You got 61. Anybody else get 61? I'm surprised it didn't have any like 61.2 in there, huh? So it's just a 61? Awesome. Now, and what's the symbol for this? We got to get used to this notation. X with the bar over it. And we call it X bar. So X bar is the symbol for the sample mean. Call it X bar. It's an X with a what? A flat bar over it. So when you hear the term X bar, you're like, someone's talking about the sample mean. That means the average. Kind of what's going on in the middle. All right, I'm going to put a line. Great job of finding a sample mean. Hey, do you agree when you got to do this for like 50 or 60 numbers, isn't it appropriate to use software? Or our calculators? Or Microsoft Excel? Absolutely. So that's what we'll do. I'll talk about that next class. You go, can I just put these numbers in and let it, I know how to add numbers up. I know how to do that. Can we let this facilitate that? Yeah, welcome to statistics. That's what we do. We know what to do, but let's let this facilitate that type of mathematics. We know it's giving us an indication what's going on in the center. The next word is the median. Now when I say median, would you think middle? Like in the road where they pushed all the snow? You get your lanes, you get the median in the middle, right? Yeah. Well, I guess it's the middle number, huh? So before we get the middle number of this, I want to give you an exercise here. Ready? I'm going to give you some numbers. 6, 3, 1, 2, 4. Can anyone see my 5 numbers right now? I'll get other way so you can see. Everyone see that? I want you to find the median of these 5 numbers. Well, Professor Messer said it's the middle number. So is the answer 1? No, people are shaking their heads, going no. What's the first step? Step 1 is, what do you got to do with the numbers?
Put them in ascending order.
Put them in ascending order. I like how you said that. You could put them in descending order too. But she's right. She's like, you got to sort these like lowest to highest first. So let's put a line through this first. Here. Can you write these lowest to highest? Like she said, ascending order. 1, there's a 2, there's a 3, there's a 4, and then a what? 6. Now, can you find the middle number? What is it? Oh, there, let's circle it. There's your median. Now I know what you're all thinking. This is an easy process. Yeah, but what if there's an even number of values? So let me do something. No, people know what to do. Let me add a number to this mix, okay? So you got your 1, your 2, your 3, you got your 4, your 6. I'm just going to put a 10 in this mix. Now the median isn't 3 anymore. So how many total numbers do I have? 1, 2, 3, 4, 5, 6. I'm going to go off to the side, everyone. What's 6 divided by 2? 3. So what I'm going to do is, I'm going to count up to the 3rd position. 1, 2, there it is, the 3rd position. I think I'll put a rectangle on it. And then what's the number right after it? What I'm going to have to do is, to find the median, I'm going to have to take the number that's in the 3rd position. I'm going to have to add it to the number in the 4th position. And then I'm going to have to divide by a what? 2. Students know what to do. I love it. I'm going to have to do that. They're like, add these together, divide by 2, or in your head you can just do what? Figure out what's in the middle. True? So what's in the middle of a 3 and a 4?
3.5.
So, would you do me a favor? go find the median of this. Good news, it's already sorted, right?
Uh-huh.
All right, now would you go find the median in this group? And notice, on purpose, yep, I've got 10 numbers. So what's 10 divide 2?
5.
10 divide 2 is a
5.
5. So which two numbers will I have to add together?
5 and 6.
Okay, the number in the 5th position, and I'm going to have to add it to the number in the
6 position.
6th position. Now if you just want to use this, I know I got them up there. Look, 1, 2, 3, 4. There's the number in the 5th position. There's the number in the 6th position. But be careful on the test. I want you to find my error. Oh, I'm going to ace this test. Here's my median. 2 plus 5 divide 2. What's my error when I was reading the stem leaf plot incorrectly? What did I do wrong?
You didn't read.
That's not the number 2. That's not, what was this number?
52.
Oh, 52. And then I'm going to add to what? 55 and divide by 2 and what do y'all get?
53.5.
So the median's 53.5. The mean is 61. It's called the sample mean. Hey, if you're curious, what's the symbol of the population mean? I'm going to get used to these symbols, but I'd like to show it to you now. What if this was a population and you had to get a mean? The symbol's a Greek symbol, and it's mu. So can I just write that over here? Everyone, just for your notes, because you'll see it throughout our course. You go, what's the symbol for a measurement of a population mean? You know, populations can be in the millions, right? Well, the symbol is the Greek letter mu. It's pronounced mu. Okay? Just so you can get used to that. I just put that off to the side. 2 more things. We're out of here. It's going to take a minute. The word mode. Mode. When you hear the word mode, I want you to think the number that occurs the most. So MO, which number occurs the most? So go in here, everyone. What occurred the most out of all those
43.
numbers? The 43. How many times did 43 happen?
Twice.
So our mode is the 43. Is it possible that you would have no mode? Yeah. Or could you have a tie for a mode? Sure. Yeah, on the test, I'll make sure there's a mode. So double check when you go, wait, I didn't find a mode. Go look back at the table again. Cool. Hey, right before you leave, I just wanted to say this. 2 measurements of the middle. Okay? When your data is bell-shaped, it's more appropriate to report the mean for the center. Okay? When your data is bell-shaped. But if your data is skewed, like skewed to the left or skewed to the right, what's a better indication of the middle? The median. Someone got that? So if your data is skewed, it's better to report the what? The median. If your data is bell-shaped, it's better to report the mean. You want to know why? What can happen with skewed data? Let's say I'm doing values of homes. I got a lot of homes that are like 100,000 or 200,000, 300,000. But then there's a guy, a couple streets down, everyone, his property is worth $32 million. What can that one number do to all the other numbers? In terms of calculating the mean. If I get to add things up, it can what? Yeah, it can really throw it off. I'll talk more about that next class. Cool? Awesome. Hey, great job, everyone. We'll start there again next class in 3.1.
Calculus is more analytical.